Assalamu alaikum. We know when an object do not change its position with time, then it is said to be at rest. In this video, we are going to discuss the concept of rest and motion. Suppose I take a point denoted by letter A. If I ask to get the position of this object A, then it may be difficult. One cannot give the exact position of the object A. Only one can say that it is on board. Where it is located, that cannot be said that easily. To get the position of an object, we use coordinate system. If I draw a coordinate system, which comprises of x, y and z axis, then now I can easily give the position of this object A. I can say that object A is at a distance of 3 inches from z axis and at a distance of 3 inches from y axis. So the exact position of point A can be obtained using this coordinate system. Here, the coordinate system which is used to get the position of an object is usually referred as frame of reference. We call the coordinate system used to get the position of an object as frame of reference. A frame of reference plays a very important role to get the position of any object. This is what tells us whether the object is at rest or in motion. Suppose there is a person sitting inside a moving bus. With respect to a co-passenger, the person is at rest. But when the same person is seen from outside, then he is said to be in motion. Here, the moving bus acts as frame of reference, using which one can easily find out the position of an object. Okay. In physics, conventionally we use this kind of coordinate system. Now, if you look at this carefully, you may find that here three axes, x, y, and z axes, are arranged in anti-clockwise direction. You can see they are arranged in anti-clockwise direction. Such a coordinate system in which axes are arranged in anti-clockwise direction are called as right-handed coordinate system. Right-handed coordinate system. Coordinate system. Okay. And one more thing you need to know about the coordinate system is here three axes are mutually perpendicular to each other. So what does it mean, mutually perpendicular to each other? It means that if you take any two axes, you will find that they are perpendicular to each other. Now, if you find the angle between y and z axis, then you may find it is 90 degree. So they are perpendicular to each other. If you get the angle between x and y, then it will be again 90 degree. In similar way, if you find out the angle between x and z, then again it will be 90 degree. But from the diagonal, the angle between x and y or the angle between x and z, do not appear to be 90 degree. Why is it so? Let me explain. Here, to make you understand this, I take a 3 chalk piece of different colors. I use this chalk piece to represent the y-axis, which is acting towards this side. Then the violet chalk piece represents the z-axis. Then this blue chalk piece will represent the x-axis. Now these two things are clear, quite clear from the diagram. They make an angle of 90 degree. So they are perpendicular to each other. But x-axis, actually this x-axis is projecting outward, projecting outside the board. Here we cannot draw a line which is projecting outward. So we have drawn an inclined line. Actually, it is need to be presented in this manner along the direction of this blue chalk piece. Now if you look at if you find the angle between these 3 chalk pieces which represent x, y and z axis, you will find they are mutually perpendicular to each other. Now x axis and the z axis make an angle of 90 degree. Similarly, the angle between y and z axis is 90 degree. Similarly, the angle between x and y axis is again 90 degree. I hope you have understood. Now, suppose I have a coordinate system which appears something like this. 3 axes acting mutually perpendicular to each other. But in this case, I take a x-axis here, y-axis here, and a z-axis here. Then here the axis rotate in clockwise direction. We call this kind of coordinate system as left-handed coordinate system. Left-handed coordinate system. Coordinate system. And here it is named as left-handed. Left-handed y acting upward. So left-handed y up coordinate system. And this one is nothing but right-handed z up coordinate system. Then I'll show you few other types of coordinate system as well. Well, if I draw a coordinate system like this, I'll take this one as the right-handed coordinate system. Keep x word, x, y, and z. This is x, y, z. It rotates in anti-clockwise direction. So it is nothing but right-handed x up coordinate system. Okay, then I draw one more type of coordinate system. Now I keep y-axis up, x here, y and z. Now this one to be rotating in anti-clockwise direction. So whenever a coordinate system rotates in anti-clockwise direction, then We call it as right-handed coordinate system. So this is a right-handed y-up coordinate system. So these are different types of coordinate system. They are also referred as Cartesian coordinate system. Okay. When the coordinate system, I repeat, when the coordinate system is used to get the position of an object, then it is referred as frame of reference. Clear? And why do we call this one as the right-handed coordinate system? Let me explain this to you. Now, just now I have told you, here x, this inclined line actually represents a line which is projecting outward. So, if you place the fingers, 1, 2, 3, 4 fingers of your right hand along the direction of the x-axis, and you close them. Now you move these fingers, then you may find that these fingers move towards the y-axis and the thumb shows z-axis. So see, so we call this coordinate system as right-handed coordinate system. Clear? I hope I have understood. This is how one can easily say whether the object is at rest or in motion. Let me tell you when an object will be at rest. See, suppose we have an object O here, it's an object O here, object O. If this object remains here even after some time, then the object is said to be at rest. No? Rest. I repeat, when the object do not change its position with time, then it is said to be at rest. And when the object will be in motion, suppose I have an object here at point E. Okay. After some time, it is found that this object has moved to point B. Now, the position of the object has changed with the time. Then the object is said to be in motion. I hope the video is useful. If you have any kind of doubt related to the topic, can you put a question in the comment section. Thanks for watching.